Okay, hi again everybody. I'm just working through some example questions here from exercise 6B and exercise 6E. Um, Remember the techniques I've talked about for factorising. We always look for the highest common factor first, then difference of perfect squares, perfect square trinomial, a monic quadratic trinomial, a non-monic trinomial, and then we complete the square. That's our technique for factorising. We work through those things and I look for them in this order because I think that's the easiest process. We're just going to run through some questions here from number 2 and from number 3, and hopefully that can help reduce some of the confusion that you may be having. The first one I'm going to look at is, let's actually just do 2A. We'll start with the simple one first and we will build from there. So x squared minus 4x plus 4 is the question, and I go through my process over here. So I look first, is there a highest common factor? And I can pretty quickly see that there isn't. Second thing, I know it's not DOPS because it hasn't got that minus sign between two terms. We've got 3 terms straight away, so we're looking for one of these factorisation techniques, which are the trinomial ones. Perfect. So we've got a trinomial. The third one I try is the perfect square trinomial. Now the way I check the perfect square is I take my middle term here, negative 4, I halve it, or divide by 2, and then I square it. And if the answer to that is the same as this value right here, then it's a perfect square trinomial. So let's actually work out what is minus 4 divided by 2 squared. Well, minus 4 divided by 2 is minus 2, and minus 2 squared is absolutely positive 4, so it does equal the final term on the end. So that means this problem here is a perfect square trinomial. And they are really easy to factorise, because I can just go now, it's a perfect square trinomial, and it'll always just be x, whatever this value here is, minus 2, all squared. And there's my question factorised. Alright, now I remember when I was in high school, I never spotted these perfect square trinomials. So let's just actually have a slightly different look at the same problem. If I move down my factorisation list and move into the monic quadratic trinomial, I know that this question is a monic trinomial because it's got a 1 in front of x squared. And my monic quadratic trinomial process for factorising is I look for 2 numbers that multiply to equal positive 4 to equal that value on the end of the expression. And I need the same 2 numbers to add to equal negative 4 to equal that middle term in the expression. Right, hopefully my colour coding is helping work out what's going on here. And I quickly work out if I have negative 2 times negative 2, that equals positive 4, and negative 2 plus negative 2 equals negative 4. So my 2 factors have to be x minus 2 and x minus 2, which really quickly becomes x minus 2 all squared. So if you're having trouble with a perfect square trinomial, you can skip that process and just work on the monic quadratic trinomial method. The perfect square trinomial does link very nicely with what we do with completing the square, and it will save you a lot of time when you get good at picking that process. Let's have a look at a slightly harder one. Same idea. Let's have a look at f up here, and x squared minus x plus 1/4. So x squared minus x plus 1/4. So same thing again here. There's no highest common factor. It's not a difference of perfect squares problem. The next thing I do is I check, is it a perfect square trinomial? Okay, for my check, I halve the middle term. My middle term is negative 1, so I halve negative 1, which gives negative 1/2. Then I square it. Negative 1/2 squared, when we square a fraction, we square the top line. Negative 1 squared is 1. We square the bottom line, which is 2 squared is 4. And it absolutely equals that value. So it does equal that, tick, tick, tick. It is a perfect square trinomial. So now to factorise it, it's just going to be x, whatever this value is, minus 1/2. Wow, that 1 almost looks like a 2, so let's make sure we know that's a 1, all squared. And it's factorised. So perfect square trinomial technique can help. Okay, let's go a little bit further then. Let's have a look at another technique. Let's have a look at this completing the square process. And we can kind of cheat. We can jump through all of my factorisation techniques here and go straight to completing the square. But the one technique that you can never forget to try first, always look, is there a highest common factor? And if there's a highest common factor, you must take it out. Okay, I'm going to do 3a here. X squared minus 2x minus 1. So I've got x squared minus 2x minus 1. And this is where the synergy comes in with, and I should actually say, complete the square first and then solve these equations. This is where the connection comes in with perfect square trinomial. Because when I'm completing the square, the first step I take is I halve this middle term and I square it. So the middle term was -2. I've halved that and squared it. And what I'm going to do to complete the square is I'm going to take that value and I'm going to add it to my equation. So I'm going to add -2/2 squared, and then I'm going to take it away again straight away. And what that essentially does is add 0 to the equation. I can add 0 to the equation. That means I haven't changed its value at all. That looks like that. By doing this and following this process, these first 3 terms now are always a perfect square trinomial. Always, every single time. So I don't even have to think about it. I just factorise those first 3 terms by writing x, whatever this value is, -2/2 all squared, minus -2/2 squared minus 1. And it's equal to 0. So now I've just got to tidy this up, and we probably should have recognised before that -2 divided by 2 is just -1. So in my brackets that becomes x minus 1 all squared. Then -2/2 is -1, and then if you square it, -1 squared becomes +1. So that's -1, -1. And note that second -1 I just drew is this -1, and this one's this -1. And all of that is equal to 0. Sweet, tidy that up just a smidge more. We get x minus 1 all squared minus 2. And the equation equals 0. Now we've completed the square, we can solve this equation. And what I'm going to do to solve this equation is I'm first going to add 2 to both sides, which makes it x minus 1 all squared equal to 2. I'm then going to take the square root of both sides. And remember, when I'm solving equations and take a square root, I get a plus and a minus as my answer. And then finally, I'm going to add 1 to both sides. And to make it look a bit neater, I'm going to put that +1 in front of the plus or minus √2. So here are my 2 solutions to x. They are 1 plus √2 and 1 minus √2. Completed the square and solved. All right. One extra technique that we can take from this space right here. We've sort of just done the first part of completing the square. If I finish completing the square to fully factorise, let's have a look at what that looks like. When I get to this stage here, I'll write it out the correct way. Rather than just rearranging my equation equal to 0, if I finish factorising, this is the difference of 2 squares. All right. So when I factorise this, it becomes x minus 1 plus √2. x minus 1 minus root 2. See my previous video on difference of perfect squares factorisation if you're not quite sure what I did there. And that's equal to 0. And then now that we've got it fully factorised, we can use the null factor law to solve this further. So either x minus 1 plus root 2 equals 0, in which case x equals positive 1 minus root 2, or x minus 1 minus root 2 equals 0, and x equals 1 plus root 2. Same result, slightly different technique. We've used the null factor law instead of rearranging. Okay, let's make it a little bit harder. Let's choose something that's a bit tricky here. I'm not going to do this one with k's, although I really want to at the moment. I am going to do this one over here with a 3, because this type of problem will throw people. So it's 3x squared minus 5x minus 2. 3x squared minus 5x minus 2 equals 0. Now, my process, the question directs me, it says that I have to complete the square, so I'm not going to try and do this another way, I'm just going to complete the square. But whenever I'm completing the square and it is a non-monic trinomial, the first thing I have to do is I have to take that 3 out as the highest common factor. And when I do that, 3 doesn't actually go into 5, so I just simply write 5 over 3x. 3 doesn't go into negative 2, so I write it as 2 over 3. And I've taken out the highest common factor. Once I've done that, I can complete the square for this part of the expression. Okay, so just put this 3 aside for the moment. Let's just work with the bit inside the brackets and complete the square for this process. Although I've got fractions, the technique's exactly the same. I halve the middle term. So my middle term was 5 over 3, and I have to halve it. And then I square that term. Now that looks super ugly at the moment. So before I go any further, I'm going to deal with this minus 5 over 3 divided by 2. And that becomes minus 5 over 3 times by 1/2, which is minus 5 over 6. Or the shortcut, I don't ever have to do this process. I'm telling you every single time what will happen is when I halve a fraction, the denominator will get doubled. So it becomes negative 5 over 6 all squared. Now remember, our next step of completing the square, we take that negative 5 over 6 all squared and we add it to the equation, and then we subtract it from the equation. My first 3 parts will always form a perfect square trinomial, and so I start with the x, and then the second value in that bracket will be whatever I had inside the brackets there. So that negative 5 over 6 goes inside my brackets. On the outside, negative 5 squared is 25, 6 squared is 36, and I've got minus 2 over 3 out there as well. Bit of tidying up. Deal with these fractions outside my squared box. They are going to become negative 25 over 36 minus times this one by 12 times this one by 12 minus 24 over 36, which is quite a nice fraction. Minus 5 over 6 squared minus, actually not as nice as I hoped, minus 49 over 36. That's still going to be a pretty good fraction because I have the difference of 2 squares. So I can continue factorising this using the difference of 2 squares. So I get the first term, the square root of the first term plus the square root of the second one. And the square root of 49 is 7. The square root of 36 is 6. then I get the first term, the square root of the first term minus the square root of the second term, which gives me that, and it's got to be equal to 0. From here, I can put together my fractions. I get x plus 2/6 and x minus 13/6. That's not even correct. That should be 12/6. Minus 5 minus another 7 would be minus 12. Equals 0. Tidy up those fractions. 2/6 is 1/3 and 12/6 is 2. So my solutions to this equation are x equals 2 or negative 1/3. And I'm done. I hope those videos